Welcome. In this video, we are exploring the essential building blocks of digital electronics, logic gates. From the computer, you are using the phone in our hand. Logic gates are the key components that power modern technology. So, what are logic gates? In simple terms, a logic gate is an electronic device that takes input signals, usually in binary form, and produces a single output. Binary, that is right. 1 means on or true, and 0 means off or false. Logic gates are fundamental commons in digital electronics that process binary signals, which represent logical operations in computing system. Each logic gate takes one or more binary inputs and produces a single binary output based on the type of gate and its logic function. Binary signals are represented as either 1 or 0. A Boolean expression is a mathematical notation for expressing logic functions using binary variables and logic operations like and, or, and not. These expressions represent the relationship between input variables and the output of a logic circuit. Logic diagrams or circuit diagram visually represent how logic gates are connected to implement a Boolean expression. Each logic gate is depicted using standardized symbols, and inputs and outputs are connected by lines. A truth table is a tabular representation of all possible input combinations for a logic function, showing the corresponding output for each combination. It lists every possible combination of binary inputs and the output of the logic gate or circuit for each combination. There are different types of logic gates are available. Generally, they categorized into three groups: basic logic gates, universal logic gates, and other logic gates. The AND gate is a fundamental digital logic gate that outputs one only when all its inputs are 1, otherwise it outputs 0. It performs the logical AND operation, which is analogous to multiplication in binary logic. The Boolean expression for AND gate is typically written as x is equal to a dot b. Simply x is equal to ab, where a and b are the inputs and x is the output. AND gates are used in systems where an action is triggered only if multiple connections are true. For example, in safety systems where both sensors must indicate a safe state for the system to operate. The OR gate is a digital logic that outputs 1 if any of its inputs is 1. It performs the logical OR operation, which is addition in binary logic. The Boolean expression for OR gate is x is equal to a plus b, where a and b are the inputs and x is the output. The OR gates are used in an alarm. An alarm will go off if any one of multiple sensors or inputs detects an issue. It can be used in circuits where an action occurs if any one of the multiple conditions is met. The NOT gate is a fundamental digital logic gate that inverts its input. It takes a single binary input and produces the opposite binary output. If the input is 1, the output is 0 and vice versa. The Boolean expression for a NOT gate is x is equal to a dash, where a is the input and x is the output, with the overline indicating inversion. NOT gates are used to invert a signal in circuits such as converting a low signal to high. It is used in combination with other gates to form more complex logic functions like NAND, NOR, and XNOR gates. In systems where an action must occur when a condition is not true, the NAND gate is a combination of AND gate followed by a NOT gate. It performs the inverse operation of the AND operation. A NOT gate outputs 0 only when all inputs are 1, otherwise it outputs 1. In simple terms, it outputs the opposite result of AND gate. The Boolean expression for NAND gate is x is equal to a dot b the whole dash, where a and b are the inputs and x is the output, with the overline representing negation. The NOR gate is a combination of an OR gate followed by a NOT gate, meaning it performs the inverse of the OR operation. The output is 1 only when all inputs are 0. In other words, if any input is 1, the output will be 0. The Boolean expression for a NOT gate is x is equal to a plus b the whole dash, where a and b are the inputs and x is the output. The XOR gate or exclusive OR gate is a digital logic gate that outputs 1 only when the number of true input is odd. For a 2-input XOR gate, this means it outputs 1 when exactly one of its input is 1, otherwise another one is 0. The Boolean expression for a 2-input XOR gate is x is equal to a XOR b. This can also be expressed using basic AND, OR, and NOT operations. The XNOR gate or exclusive NOR gate is a digital logic gate that outputs 1 only when the number of true input is even. For a 2-input XNOR gate, this means it outputs 1 when both inputs are the same, either both are 1 or 0. The Boolean expression for a 2-input XNOR gate is y is equal to a XOR b the whole bar. This can also be expressed in terms of AND, OR, and NOT operations. The applications of logic gates are used in digital circuit design. It is used to create combinational circuits and sequential circuits. It is essential in adders, subtractors for binary calculations. It is the core components of arithmetic logic units in processor and control units for directing operations. It is used in flip-flops and latches for data storage in RAM and registers. It is used to implement digital filters and algorithms for noise reduction and signal enhancement. Logic gates are involved in error detection and correction mechanism for a digital integrity. Logic gates are used to build automated systems for industrial automation and safety security application. Logic gates are found in embedded systems of appliances like microwaves and gaming consoles. Thank you for watching.